Hello. Today we are going to introduce a different topic, which is quite important. So the topic we are going to discuss today is called group theory. Okay, group theory. Let's change it to color. Okay, so group theory is dealing with the symmetry information about molecules. Okay, so for any given molecules, they have symmetry properties. Okay, so symmetry and the bonding of molecule, they are closely related. Okay, so when we consider symmetry information of a molecule, then we can get many useful information from the molecule. For example, we can use the symmetry information to constructing molecular orbitals. Okay, and also we can use the symmetry information to analyze the spectroscopy data, like the vibrational spectroscopy. Okay, also UVV spectroscopy. Okay, so there are many useful information based on symmetry treatment for molecules. Okay, and symmetry so I think you guys should have a basic impression about symmetry, right? So if you see something symmetric, that means there's a symmetry element. If you do that operation, the object keep unchanged. Okay, so that's what we call symmetry operations. Okay, so then when you have something is symmetric, then you have symmetry element there. Okay, so when we talk about the symmetry of a molecule, okay, so different molecule or even an object, okay, they have different symmetry elements as a nature associated with symmetry. Okay, then when we group the symmetry elements of a molecule or object, so a group of symmetry elements put them together, and we can assign a particular symmetry information for that molecule. So in that case, we can assign a point group to that molecule. Okay. In terms of symmetry operation, so we have as you can see here, we have 5 basic symmetry operation, and corresponding we have 5 symmetry elements. Okay, the first one is called identity. Identity means no change. The object stay there, nothing happened, just no additional operation. Then we have rotation. Okay, rotation means that's an axis. Rotation axis. You rotate a molecule around that axis. Range defined by the how many degrees to rotate defined by the order of the symmetry, the rotation axis that we could unfolder. Okay, so we will give you a specific example later. Okay, so another one is reflection. Okay, like a mirror. So if you do reflection for the molecule, no symmetry change. Okay, or inversion. So like we talk about the inversion center for sigma bond and the pi bond. Remember, so that's how we get G and U sign for the sigma bonding based on s orbital, and pi bonding based on p orbitals. Okay, and another one is called improper rotation. That's called SN. Okay, SN. So for each one, we have a symbol to represent the symmetry operation. So E is identity, Cn means rotation axis, sigma means mirror plane, I means inversion center, Sn means improper rotation. So I'm going to use the example to explain each of them. Okay, each of them. Okay. So the first one is the rotation. Okay. So we don't talk about identity element. Identity means no change. Okay, that's no change. That's the most basic symmetry element for any given molecule. Okay, so no change. Okay, so let's talk about rotation. We can use water molecule as example here. That's a water molecule. They have one hydrogen here, one hydrogen here. So central we have oxygen here. So if you draw axis, okay, along the oxygen atom, so as shown in the blue line here, we call that C2. That's 360 divided by 2. That's a 100-degree rotation. So if you along this blue line C2 axis rotation 180 degree, you can repeat this water molecule as the same one. Okay, so for this molecule you have a C2 rotation. Okay, C2 rotation. And here is the ammonia molecule. You can see there's a C3 rotation if you draw axis perpendicular to the screen through the nitrogen atom here. So you will have this C3 rotation. Okay, C3 rotation. And so rotated by 120 degree, and you can repeat the molecule. Okay. Then also what you do if you rotate twice of the C3, okay, then you can also repeat this molecule. Okay. So one is we call the 120 degree as C3 rotation. Another 240 degree we call that a C32 rotation. So they have two rotation operations. Okay. And next one, let's discuss the reflection. That's a mirror plane. Okay, mirror plane. So let's still use the water molecule as an example. Okay, so you can see as you can see in this slide. So you can draw two sigma, two vertical plane as a mirror plane for this molecule. One is you can say you have a plane contain oxygen perpendicular to the HH vector here. Okay, then if you use this mirror, so you can say this hydrogen will go to this position, and this hydrogen will come to this position. Then you can still have the same molecule. Okay, same molecule. Another way is you can have a mirror plane contain 3 atoms. Okay, then if you do reflection, you still get the same molecule. Okay, that's the first one we call that as sigma V, and second one we call the sigma V prime. So there are two vertical mirror refraction planes. Okay, for this water molecule. Okay, let's look at the inversion. Okay, so inversion operation. Okay, inversion means it's a inversion center. Okay, it's center based symmetry operation. So let's look at the sulfur F6. Okay, sulfur F6. Okay, so in this molecule you can say that's octahedral. Okay, that's octahedral geometry. Okay, you can say you can put a center on this sulfur atom, right? Then if you do inversion, you can say that, for example, if you do inversion, you will say 3 move to 5, 5 move to 3 position, and atom 2, fluoride 2 move to 4 position, and 4 move to 2 position, and you still get the same molecule for this F6 molecule. Okay, that's an inversion. Okay, inversion. Remember, so when we talk about the pi bonding, right? Remember. So that's pi star, remember. Also, we call that as pi g, right? Right? Why is g? Because g means, the shape of this pi bonding symmetric with this inversion center. Okay, inversion center. Okay, so just record the pi g. So what's the meaning of g? Okay, G versus U. When you have U, that means asymmetric, right? So okay. Okay, the last symmetry operation we're going to discuss here is improper rotation. Improper rotation. Okay, and let's look at the this molecule. We call that methane CH4. So that's this one has that's a tetrahedral point group. So we'll talk point group later. Okay, just give you an answer here. See the 4 hydrogen atoms we're showing here with different colors for 4 hydrogen atoms here. Okay, and if you draw a C4 symmetry here, okay, C4 symmetry here, axis, rotation axis, okay, if you rotate this molecule along this blue C4 axis, okay, what happened is your, this atom, right, the blue atom will move to the 9-degree, to the plane perpendicular to the screen. And if you treat these 3 atoms as a plane, right, if you rotate the 9-degree, right now this plane is in screen. If you rotate 9-degree, this plane will become perpendicular to this screen, right? Same thing happened to the to this plane. Okay. So it was perpendicular to the screen. Right now it's in the screen. This plane, okay, in the screen right now. Right, you see after this C4 rotation, the methane is not keep the same, space arrangement, right? Because the blue moved to this position, right? However, if you apply a reflection plane as showing here, reflection, okay, reflection operation. So what happened is you are going to move the blue atom to here, orange atom to here, after reflection, orange to that, and green to this side. So you will see these 2, they have same, spatial arrangement for this molecule. Okay, so that's called improper rotation. So improper rotation consists 2 operations. Okay, one is Cn and plus sigma. Okay, you have rotation first, and then you do a reflection. So then that's called Sn. Okay, Sn operation. Okay, improper rotation. Okay. So let's look at some more information. Okay, more symmetric information. Use a square planar molecule. Okay, so that's an example. Okay, that's an example too. We can put all this. We can discuss all different symmetry operations in this molecule. Okay, so let's talk about the Cn. Okay, the Cn called N. It means the principal rotation with the largest n value. Okay, or which means you need to rotate the smallest angle with that axis. Okay, that axis Cn is the principal rotation. Okay, so in this case, the principal rotation is going to be the one if we draw a perpendicular line through the screen, go through this silver colored atom. So we're going to have a C4 rotation, right? That's your principal rotation. And also, if C4 rotation means you just need to rotate 90 degree, you can rotate the molecule. But for the same axis, you can also rotate 180 degree. You can repeat the molecule. That's called C2. Okay, C2. And also you have other C2. One is a green line here. Another one is a red line, red axis line. They are C2 prime and C2 double prime. They are perpendicular to the Cn. Okay, there are two additional C2 rotation axes. Okay, then we have different reflection planes here. Okay, the next one we're going to see is sigma h. So sigma h is the reflection perpendicular to the principal rotation axis. So that's a plane contain all these 5 atoms here. Okay, and next one is sigma v. Okay, sigma v is one that's vertical reflection. Okay, vertical reaction. So that's a contain the rotation, principal rotation. Okay, so that's the one. Okay, the one cross the atom. Okay, that's sigma v. That's plane perpendicular. So you have 2 sigma v here. Okay, and also you have sigma d. So what's a sigma d? Sigma d also contain the principal rotation, but it's bisect to C2 prime rotation. Okay, C2 prime rotation. So the C2 addition C2 is one is here. It's here. Okay, and then that's a sigma d. Okay, that's a bisect. Okay, another way you can tell the difference between sigma d and sigma a is sigma v normally cores more atoms, and sigma d contain less atoms. Okay, the plane. Okay, so that's difference. So, and we can use more example to tell the difference between sigma v and sigma d. Okay, so like in this benzene case, you can draw many, you can draw it's 1 2 3, you can draw 6, right? 3 is orange, orange color, another 3 yellow color. So there are 6 vertical reflection plane perpendicular to the benzene molecule, right? Perpendicular to the benzene molecule. Okay, but then how can we tell that which one is sigma v set and which one is sigma d set? So as I said, the orange is sigma v because it cores more atoms. Okay, now sigma d is the yellow set because it does not contain, it contains no atoms. Okay, they're perpendicular plane. Okay, same thing here. So for the ammonium molecule, you only have 3 sigma v plane. Okay, 3 sigma plane. And if you look at the stacked acid molecule, so what you can have is you can have the orange. Okay, this 3 yellow plane there. Okay, they are sigma v2. Okay, sigma v2. Okay, and yeah, in this case we don't have sigma d. Okay, sigma d. Okay, so here are 2 criterion you can tell the difference between sigma v and sigma d. Okay, sigma v and sigma d. Okay, so normally sigma v plane contains more atoms compared to sigma d. Okay, so if one perpendicular, if you see only one type, in this case we have sigma v. In this case we have we call that sigma d. Okay, so so the first one is in this case we don't have C2 axis. Okay, because you don't have C2 axis bisect by the sigma v. That's sigma v. And sigma d here, because in this case we have this C2 rotation axis perpendicular to the 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 principal rotation here. Okay, principal rotation here, C3 rotation. Then we call that vertical reflection as sigma d. Okay. So I'm going to make stop here so we can discuss more symmetry information about molecules next class. So we are going to dealing with a point group and okay, dealing with point group. Okay, I'm going to make a stop.